Hello everyone, welcome back to another episode for this program. In this program, we are going to begin our model with SolidWorks animation. SolidWorks animation is a part of SolidWorks that gives your model an automated movement for some visualization and some demonstration before the actual production begin. So I'm going to begin the animation using my design that I made for my final year project. So what you see here is the prototype that was used to test run my blade, because what I actually did was that I used SolidWorks to design this blade and I 3D printed it for my final year project, and then it worked perfectly and it flew successfully. So now for the course of this training, I'm going to use this model to demonstrate how animation simply works. Before I continue, I want to clarify some things over here, that my project was only limited to the blade, but the rest of the model it was already made, so I just followed the pathway to design them in SolidWorks. But the good side of it is that when I was able to test run it, like I was able to display the animation, it gave my presentation some level of um some level of decency. It makes it look kind of professional. That is, even though the project was not brought to them in real form, at least the animation helped them to understand the concept of the whole project. So wherever you are trying to design your big project that requires some intricate shape, you will be able to demonstrate its functionality using SolidWorks animation. So animation is a very good software, a good tool in SolidWorks, and it can be done by just focusing at the necessary parts. So now I'm going to go straight forward to SolidWorks to see how we could model our SolidWorks, our animation, and see what we can do about it. Now, this is this. So now this interface is when the assembly interface. You can see that each part have their respective location in the trees. Everything is this helicopter alone. It took up so many parts, so it's a very tedious it's a tedious process for me. It took me weeks to complete, and also after doing that I took my model into animation by simply clicking this section below, which is called the motion study. So now let's click one of the motion study to see what animation looks like in SolidWorks. So now if you're going to create your own, you can click motion study 1, motion study 2, motion study 1. So let's see what it asks for us. So now this is our motion study. That is, every functionality in this SolidWorks is represented by this timeline below. Now in animation you are going to realize that you have some new features that you're gonna have to lay your hands on. That is, this section is a timeline. This is a timeline, and then the timeline has its own specified component. This component you see here is actually a new kind of component in animation. That is, the animation interface has its own part for its assembly. So this part does not have anything to do with our main assembly. So when I drag this thing down, you will see that our our main part is here, that is the part for the for the project is here, but animation has its own special part where you can take advantage of the model and use it for your animation. So that's actually what it I need to know. And also you can see some keys, some kind of colors, and some kind of changes in this timeline. So the goal of it is to ensure that any kind of movement by the demonstration can be adjusted by all of this simply by just tweaking all of these keys, placing the right keys in their respective location, which will be able to give you the animation that it deserves. And also you have some commands over here. You have like the save animation. You have the animation wizard, the auto key, the motor, the spring, and all of the things that the animation is required. We have the calculator. We have the play from start, and then the play. So as specified by the course of this program, we am going to I'm going to this program is actually dealing with animation. But in SolidWorks has many other things apart from animation. We have the basic motion, then the motion analysis. So the basic motion simply requires some physics kind of input inside. That is, when it has to do with basic motion, all the fundamental force of nature, like the gravity, the frictional force, the contact force, and any other force must be put into consideration. So it's more like physics inside your basic animation, not just mere animation that you can just design it for anything. So if it has to do with real life scenario, basic motion is what you can consider. We also have motion analysis. So motion analysis also points some specific parts of SolidWorks, like the inertial force, where the force is being concentrated, and also the pressure of each of the component. So if you are dealing with a component that has to do with precision, every part of the component must be brought into account. So that is actually what basic motion and motion analysis can bring for you. But animation is just like what it's just a normal command. It does not have any fundamental force attached to it. It's just a cartoon that you use for your demonstration. So the program is actually going to be dwelling on animation alone. Other part of this part will be discussed in a future course, but for now we're just going to stick with this one. So what I'm going to do now is that I'm going to play back the cartoon for you to watch and see what this thing is all about. So I'm going to play right now. So this is actually what my animation brings for me. So it's actually a simple illustration of what you can use animation to do. Now just take a look and see what it's gonna do. Okay, so that's actually all this motion study one. This is actually everything that was designed in motion study one. So let's take it to motion study 2. Let's see what it has for us. So motion study 2 has some things similar to motion study 1, and let's see what it actually has for us. Okay, this is actually another rough animation. So this is actually my second animation. I actually remember when I did this one, I was, even though it wasn't as perfect as it's supposed to be, but the excitement that I was able to make my animation is actually it actually makes me happy. So as time proceeded, I designed, went to motion, I began to perfect my skill in and solid animation, and then it was very fun. So I'm going to play my last animation for this particular project, and it was very interesting. So I'm sure you must have watched this before, so let me replay it again. Okay, this is actually the end of the model, so I'm going to drag it to where it began. So let's see. So now this is actually how I was able to perfect the animation in Solidworks. So you can see that a model that is as simple as basic as this can be designed in a way that it looks very cool and looks like a big deal, because of the effort that was made in terms of animation. So this thing was helped me to demonstrate how the concept of the helicopter will look like, the house helicopter, which give me some manner of upload in my presentation when I was doing my final year project. So this is actually one of the things that Solidworks animation have in store for you, and with time, with consistency, you'll be able to do it as well. So now I'm going to replay this thing. That is, anything that this project does for us is just like a script given to it. So animation, I actually give the animation an instruction on the action that must be taking place to give it what it should do. So if I replay the animation from the beginning, you will see this time bar moving from this starting point down to each of these things. That is, any of this key that was the changes of this key represent the respective moment of each of the component. You can see these are actually the changes that was made, and then as time progresses, further changes made everything work like a real life display. So everything that you saw in Solidworks animation does for you is basically the changes of all the keys you see here, and then it's going to move to where it ends. So the duration of the animation is just 50 seconds, and that's actually what you need to know about Solidworks animation. So now I'm going to be frank with you. You won't be able to design everything as of now. It needs to be done step by step, and then the animation itself is a very, very complicated part of Solidworks. I will not lie to you, it's a complicated part of Solidworks that it needs some level of consistency, level of determination, and practice before you'll be able to achieve your aim in Solidworks animation. So for the sake of this class, I will presume that you are pretty new to animation, so we're not going to dwell on this model today. Rather, we're going to start with something very, very simple for us to design. So I'm going to design our assembly in animation. So now, if you are actually following my class if you will be following my class, you will realize that we are able to design a particular model. Okay, I don't know where. Okay, this is the model. Okay, right. So now this is our assembly for the course outline, and you see that the assembly you see right here has 3 parts, the which were given its respective name. And then let's take this thing, let's use this thing as an example in animation, and let's see what this basic design can do for us. So what I'm going to do now is to go to okay, let's go to a new assembly. Okay, so now I should have gone to a new assembly, but I'm going to just continue from where we actually started from. So now, for you being for you starting assembly, like if you are starting assembly, your first time starting assembly, you are going to see this you're going to see this display, motion study one. That is, any motion, any animation you've done will be stored at this very tab. So if you could remember, I deleted the motion study tool. That is, I've already worked on the animation part of it, but for you that have not done anything animation, is going to display as this very one. So what you're going to do is that if you want to go to an animation, what you're going to do is to go to, just click this section below, and then your animation begins. So for some system, your timeline should pop up like this, not like this. Actually, it's supposed to be empty as this. But if your one does not pop up like that, you just go to this icon over here, then you press it, then the animation timeline comes out. So now, simply because we have worked on this very model before, I'm just going to start a new motion study. So how do we start a new motion study? I just right click on this model, and then you see create new motion study, so you click it. Now this is now another new motion study. So do not confuse my terms together. Motion study generalize the animation, the basic motion, and motion analysis. You understand? But in this particular course, we are just going to dwell in animation. But motion study it's a term that used to generalize what we're actually doing right now. So you don't be confused by words. So now this is actually what we have in our motion study, and as I've said earlier, this is actually the timeline. And the timeline is in seconds. It can be in minutes, it depending what you're actually working with. So this is actually in seconds, and then if I can zoom out, you can see that seconds is now becoming minutes. So what actually started at a second is now 1 second, 0 seconds, 1 minute, 40 seconds, 3 minutes, 20 seconds, and beyond. So if I begin to zoom out, you can see that each section as is becoming more smaller, and now you have 16 minutes, 33 minutes, and 1 hour, 1 hour 40 minutes, 2 hours, and moving forward. So now animation, you can do animation to any length of your choice, as long as you are just making sense in what you are trying to design. But you just have to be mindful of the system that you're going to be using for your animation, because animation is a very, very delicate part of Solidworks that it takes a computing power to achieve. So make sure you take note of the spec of your computer before you considering animation. Just like my system now, I'm being mindful of the time that is allocated for the animation. If not, it's going to mess up with the system power. So that is what you just need to consider. So another thing is the command. That is all these are all the commands that you will see in animation. For instance, you have the auto key, this is the animation wizard, the auto key. In animation wizard, you will see the dialog which gives you the respective option, like the rotate model, exploded, the collapse, import from basic motion, scalar studies, and the rest. So this is actually what you need to do. So if you want to save your model, you just go to save animation, and it's going to convert your animation into the respective file. It could be in MP4 or AV file. So that's actually another thing. So you have motor, that is, if your motion has to do with motion, maybe you see your robot moving in a direction, you see a model Let's take a robot as an example. If you want your robot to move at a specific direction, motor is actually the place you're gonna have to go for your project, and you have the spring, the damper, and the rest. Now so these are just the basic things that you need to know and SolidWorks animation. And also we have our timeline, and we have the respective keys. So now take note of this. This section is actually the part that this part is actually, we're now in the this is the interface of SolidWorks. This is just the model part of SolidWorks, and we have another part inside the animation. That is, the part you see here is under motion study or is under animation. So there are two different things. So this part you see here is under this part you see over here. That is, this part you see here controls what you see over here. So if I can tweak all this model, or if I can manipulate them for the aim of my animation, it will not affect what you see here. But there are some things that you can change here that is going to affect the things you see down here. Okay, for instance, let's actually delete this model. Let's delete this model. It's actually for a reference. It's not, I'm going to take it back. So if I can delete this model, now you can see that the model over here is now deleted. There's nothing you can do about it. So this is just like a global entity that governs the animation you see below. So what I'm going to do now is to take it back. Now once I will do it, everything is back here. So if I can delete this model from the animation or motion study, let's see if it's going to affect the model we see over here. Okay, let's just say let's use hide. Yes, now you can see that the animation, we are now in the animation. You can see that the model in now is no longer showing, isn't it? But if I can take my model back to, if I can take the interface back to model, like this, we are now in the model tab. Now our model is back and complete as if nothing happened. But mind you, if I can go back to my motion study, the model interface has changed into the animation. Now we're not in the animation tab. The animation tab will be as though there is nothing there, because we're able to change a setting over here. So if I take it back, if I can make it to show back, I make it press show, and then it's back, and still it's not going to affect anything you see over here. Now what if I hide this thing? What if I hide this model over here? What if I hide it? Let's see the effect it's going to give us in our motion study or animation. So now I went back to my model tab, then I hide the model over here, and let's see the effect. Now in SolidWorks motion, there's nothing hidden over here. Everything is as though everything works as if they are two separate interfaces working hand in hand together. So there are some changes that will do that will not affect any of the interface, but mind you, there can be a particular interface that can be changed from one section that will affect the other section. So just take this thing into consideration, and this is actually what you need to take note of. So I'm just trying to take things to you gradually, because if I jump straight to modeling without you knowing the basic thing, it's going to be difficult for you. So now I'm going to bring back my model, so it's going to be showing, and then I'm taking back to my motion study. So now in this motion study, the motion study is given a timeline, and the timeline has a respective key, and the key is actually it works with the time allocation allocated to it. That is, what this model is doing is actually time dependent. When you consider something in motion, we know that for every motion there is a time where it begins from rest and to its final destination. That is why time is a factor when you are considering anything that has to do with motion in your basic elementary class or physics class. Time is a motion that you need to take note of. So now if I want to take my movement, if I want to make this motion, let's take this model as a model that is supposed to move from this origin to this end of my screen. I want to take it to this place, and let's see what it's going to look like. So the first thing you're going to do is that you make sure that you adjust your time bar to the time it needs to move. So now, mind you, we are in 20 seconds, so I want to make sure that for the next 20 seconds the model was able to move from this origin to this section. So now I've changed my time bar to 20 seconds. Now I'm going to move my model to this place or this place, it doesn't matter. Now you can see that by default my key, some keys are already formed. Mind you, initially all these keys, the only key we can see here is this one listed at this particular bar, but now we can see that some keys were being formed already. We didn't touch anything over here, but the keys were formed already. Now how was that? How was that? What is the explanation between these things? It shows that for the final destination of this very model, it is recorded by the final destination of this key. This key represents the plate. This particular key, you can see that this key is under the part AA, and mind you, part AA is what I used to save for the plate over here. So that is the movement from this key to this key is actually the movement from the plate over here to this very other plate, and it actually takes the other component along with it. So now I'm going to calculate my model to see what it actually has for us. So mind you, the movement, you can see that the key is trying to complete, that is the movement from here to this section is actually the time allocated for it. So now for 20 seconds our model began from this origin and then it moved straight to this section in just 20 seconds. So what if I move it to 40 seconds? It's going to move to that very section, but this time around it's going to be very slow because everything you see here is time dependent. So if I can replay it again, you can see that the movement from here to here is actually the destination. The destination is actually determined, but the time allocation for it will determine the speed of the motion. So that's actually another thing that you need to consider. So why is time a factor that you need to consider? Because the time determines the speed of the motion. So let's assume that I want this thing to come down here, like go back there, like very fast. So the thing you're going to do is that I'm going to drag this time bar. Let's say now we're in 20 seconds right now, so I'm going to drag. Okay, let me just zoom in to see the seconds that is given to us. Now consider this particular section, which is 20 seconds. Now we can count from here that this is 21, 22 and 23. So I'm going to take it to 23 seconds. 21, 22, 23. So now for the next 23 seconds this model is going to return back to anywhere close to the initial, but we cannot get the initial because we do not have a kind of key to tell us where this particular model was initially. So now I'm going to take this model back to where it's supposed to be. Like, let's take this as our initial. Now you can see that by default the motion study has given us a new kind of key, that is a new motion has been allocated to the timeline, which comes with its respective changes. Now I'm going to calculate again and see what it's going to do. So mind you, we started from here, that is the model started from the origin, and it's going to make a travel from this section to this section, then it's going to go back, and then let's see what it's going to do for us. Now you can see my explanation is pretty straightforward. So now the motion of this very model, it can be moved to any part of this. part of your graphics area, but it actually is actually at the influence of the time allocated to it. So that's actually one of the things you need to know in SolidWorks animation. So time is a factor that you need to consider in SolidWorks animation. Now before I move further, this very word is something that you need to take note of. Now at this very section, so now let's say I'm taking this model, I want to take it up, down, at every other part of the section. Let's see what it's going to do for us. So now let's shift this bar to 25 seconds. So by 25 seconds the model move down, and then the next 25 let's say 27 seconds from there, 27 seconds, yes, the model went to this area, and then to this, the next let's say to the next 30 seconds the model went down here. That is, it went straight to this section. So now let us replay everything and let's see what it has from started from this section, because this side is so long that I'm so impatient to watch it. So now let's assume it started from the origin and then it's now going to the final to this point. Now it's going back. So now everything you see here is actually time dependent. That's actually one thing you need to know. So now there's another factor you need to know in SolidWorks animation, that is the component, that this other component that you see over here. So now if you can take a look very closely, this line, this very model, is this very key represent this part, that is the part AA is this single model that you see that has isolated itself. That's actually what it is in part AA. Now it is the part AA that actually moved. None of these components moved in respect to it, but in the animation everything moved together. That is, there is a particular explanation to this why the rest of the components should not move, because normally if everything should move from their point, all of the rest of the components should move all together, because each of the component has this key represent this part, this key also represents this part. So by default everything is supposed to move together. Why is it that none of the components move? Why is it that it's only this thing that move and the rest of this component is what it stays along, but in animation everything still move? So then you can see that there's some level of conflict here, right? That can be explained by this thing called mate. Now remember from our model that each of these parts was given their respective mate. For this model to become a unit of assembly, it was joined together by mate. So each of these mates makes it to fall into their respective location. So now once it comes to animation, necessarily we do not need to move all of the parts together. The mate that was given to it will be the changes that is being made. That is, if this part, if the mate, if I can click this section, this place click yellow, that is the mate connecting this nut to this plate below is actually the mate you see over here, and then followed by the respective mate that was given to it. So now a model will move followed by the mate that is connected to the component you see over here should make it move. That's another thing I need to know in SolidWorks animation. So it's a basic that needs to be understood before we continue. Now I'm going to close for now. That is actually what we need to know about SolidWorks animation. So in our next class I'm going to show you another function that is very important in SolidWorks animation for your modeling. But as of this time now, with this one, it is just an elementary class with SolidWorks animation, and then it is important you're able to learn how it works. So in my next episode I'm going to show you another function in animation, and how you can use it to make a visual illustration for your project. So with everything being said, that come to the end of this very class. So in the next class we are going to continue from there. So thank you for watching, thank you for listening, and see you in my next class. Bye for now.